Tonight we're going to explore the most profound question that has ever haunted the human mind. Not the kind that gets answered in textbooks or settled by committees. The kind that sits in the back of your consciousness at 3 a.m. when the world is quiet and your thoughts turn toward the infinite darkness above. We're talking about the ultimate mystery, the one that science has been chasing for centuries but can never quite catch. Who or what created the universe? And more unsettling still, why does it exist at all? If this kind of deep, contemplative exploration helps you drift into thought and wonder, feel free to like the video and subscribe, but only if it genuinely brings you that sense of cosmic curiosity. And let me know in the comments where you're listening from and what time it is right now. There's something oddly comforting about knowing we're all out here, scattered across this pale blue dot, pondering the same impossible questions under the same vast sky. So settle back, let your mind expand beyond the familiar, and let's venture into the strange territory where science meets the unknowable. Because what we're about to discover will challenge everything you thought you knew about existence itself. Here's what's fascinating and deeply unsettling about our situation. Right now, at this very moment, you're hurtling through space at over 500,000 miles per hour. You're riding on a rock that's spinning around a nuclear furnace, which itself is racing around the center of a galaxy containing hundreds of billions of other stars. And that entire galaxy is rushing away from countless other galaxies at speeds that would make your head spin if you could truly comprehend them. But here's the strangest part. None of this should exist. Not you, not the Earth, not the stars, not the vast cosmic web of galaxies stretching across billions of light years. According to our best understanding of physics, the default state of reality should be absolutely nothing. No space, no time, no matter, no energy, just pure, perfect nothingness. And yet here we are, impossibly, asking why there's something instead of nothing. The story begins, if we can call it a beginning, about 13.8 billion years ago, with an event so violent and mysterious that we can barely wrap our minds around it. We call it the Big Bang, but that name is almost comically inadequate for what actually happened. This wasn't an explosion in space. This was the explosion of space itself, along with time, matter, energy, and everything we've ever known or could ever know. Picture this. At the very first moment, if moments even existed then, everything that would become our observable universe was compressed into a point smaller than an atom. Not just smaller, infinitely smaller. A mathematical singularity where the very concepts of size and dimension break down completely. The temperature was infinite. The density was infinite. The laws of physics as we understand them simply didn't apply. Then, in less than a trillionth of a trillionth of a trillionth of a second, something extraordinary happened. The universe expanded faster than the speed of light. This wasn't matter moving through space, mind you. This was space itself inflating, stretching, growing at a rate so violent that it defies every intuition we have about how reality should behave. This period, called cosmic inflation, solved several puzzles about why our universe looks the way it does. But it created an even bigger mystery. What powered this incredible expansion? What force could cause reality itself to balloon from smaller than a subatomic particle to larger than a grapefruit in a time frame so brief that light couldn't even cross the distance of a proton? The honest answer is, we have no idea. None whatsoever. We can describe what happened. We can measure the afterglow of these events still echoing through space today. But we cannot explain why it happened, or what caused it to happen. It's as if we arrived at a crime scene after the fact, found all this evidence of an impossible event, but the perpetrator vanished without leaving a single clue. But the mystery deepens when we start looking at what our universe is actually made of. Everything you can see, every star blazing in the night sky, every planet, every grain of sand, every atom in your body, All of it combined makes up less than 5% of the universe. 5%. The rest is composed of substances so mysterious that we can only describe them by what they're not. 27% of the universe is something called dark matter. We know it's there because we can see its gravitational effects on visible matter, bending light from distant galaxies and holding clusters of stars together with invisible hands. But we've never directly detected a single particle of dark matter. We've built detectors deep underground, shielded from cosmic rays, waiting for dark matter particles to bump into ordinary atoms. We've been waiting for decades. The detectors sit in their underground chambers, silent as tombs. Even more perplexing is dark energy, which makes up about 68% of everything that exists. This mysterious force is pushing the universe apart, accelerating the expansion that began with the Big Bang. Galaxies are racing away from us faster and faster, driven by an energy we cannot see, cannot touch, cannot understand. The very fabric of space itself is being stretched by a force so alien to our experience that we can only describe it as the opposite of gravity. Think about that for a moment. We live in a universe where 95% of reality is completely invisible to us. It's as if we're trying to understand a vast symphony while being able to hear only one instrument out of 20. We're cosmic blind people describing an elephant, except the elephant is made mostly of things we can't even touch. But perhaps the most disturbing aspect of our universe isn't what we can't see, but how perfectly calibrated everything appears to be for our existence. The fundamental constants of physics, the basic numbers that determine how reality operates, seem to be fine-tuned with a precision that borders on the impossible. Consider the strength of gravity. If it were just slightly stronger, stars would burn out too quickly for planets to form and life to evolve. If it were slightly weaker, stars couldn't form at all, and the universe would be a cold, dark expanse of scattered particles. The margin for error is vanishingly small, like balancing a pencil on its point in a hurricane. The same precision appears everywhere we look. The mass of the proton compared to the electron. The strength of the nuclear forces that hold atoms together. The rate of universal expansion. Change any of these by tiny amounts, and you get a universe where complexity cannot emerge, where stars cannot shine, where life cannot exist. Stephen Hawking once observed that the values of these fundamental numbers seem to have been very finely adjusted to make possible the development of life. It's as if someone, or something, carefully dialed in the settings of reality to create a universe capable of producing observers who could contemplate their own existence. This raises a question that makes physicists profoundly uncomfortable. Was the universe designed? The word itself seems to carry implications that science isn't equipped to handle. Design suggests a designer. Purpose suggests an intelligence behind the cosmic machinery. But the alternative explanations are almost as unsettling as the possibility of deliberate creation. Some scientists propose that we live in a multiverse, an infinite collection of universes where every possible combination of physical laws and constants plays out. In this scenario, most universes are sterile wastelands where nothing interesting happens. But in a few rare cases, the numbers align perfectly, and you get a universe like ours, where complexity can flourish. We exist in one of the winning lottery tickets, not because we were chosen, but because we're the only ones capable of asking the question. But this explanation, while elegant, raises its own profound mysteries. If there are infinite universes, where do they come from? What generates them? What determines their laws? We've simply pushed the mystery back one level, like asking who made the machine that makes the machines. The multiverse also faces a more fundamental problem. It may be forever untestable. If we can never observe these other universes, if they remain permanently beyond the reach of our instruments and experiments, then in what sense are we doing science at all? we risk crossing the line from physics into metaphysics, from observation into pure speculation. Yet the alternative, accepting that our universe appears designed, seems to challenge the very foundations of scientific thinking. Science has always sought natural explanations for natural phenomena. To suggest that the universe bears the hallmarks of intelligence or purpose feels like abandoning the quest for understanding in favor of mystery. But what if the mystery is the point? What if we've reached the edge of what science can explain, not because we lack better instruments or more clever theories, but because we've encountered something fundamentally beyond the reach of human comprehension? What if the universe is not just stranger than we imagine, but stranger than we can imagine? The deepest puzzle isn't just how the universe began, but why it began at all. Why is there something rather than nothing? This question has haunted philosophers for millennia, but modern cosmology has given it new urgency. We can trace the history of the universe back to fractions of a second after the Big Bang. We can map the cosmic web of galaxies stretching across billions of light years, but we cannot answer the most basic question of all. Why does any of it exist? Some physicists have suggested that the universe created itself through quantum processes we barely understand. In the strange world of quantum mechanics, particles can pop into existence from apparently empty space, borrowing energy from the vacuum itself. Perhaps the entire universe is just the ultimate quantum fluctuation, reality bootstrapping itself into existence from pure nothingness. But this explanation too raises more questions than it answers. Where do the quantum laws come from that allow such fluctuations? Why do they have the particular form they do? We're still left with the mystery of why there are laws of physics at all, rather than no laws governing no reality whatsoever. The more we learn about the universe, the more mysterious it becomes. Every answer reveals new questions, deeper puzzles, more profound mysteries. We live in a cosmos that seems almost designed to make us wonder, to fill us with awe and confusion in equal measure. Whether that's by accident or design, we may never know. But perhaps that's exactly as it should be. Perhaps mystery isn't the enemy of understanding, but its deepest expression. Perhaps the universe isn't just a problem to be solved, but a wonder to be experienced. And this brings us to one of the most unsettling discoveries in modern physics. The thing that keeps cosmologists awake at night, staring at equations that refuse to make sense. It's called the cosmological constant problem, and it represents perhaps the largest discrepancy between what our theories predict and what we actually observe in all of science. Here's the issue. According to quantum field theory, empty space isn't really empty. Even in a perfect vacuum, particles are constantly popping into existence and then vanishing again, creating what physicists call vacuum energy. This energy should be accelerating the expansion of the universe, which sounds like it might explain dark energy. Problem solved, right? Not even close. When physicists calculate how much vacuum energy there should be, they get a number that's not just wrong, but spectacularly, impossibly wrong. The predicted value is larger than what we observe by a factor of 10 to the power of 120. That's a 1 followed by 120 zeros. To put this in perspective, there are only about 10 to the 80 atoms in the observable universe. This discrepancy is so enormous that if our calculations were off by even a tiny fraction of this amount, the universe would have either collapsed instantly or expanded so violently that atoms could never form. Yet here we are, in a universe that's expanding at exactly the right rate for galaxies to form, stars to shine, and life to emerge. It's as if someone took our catastrophically wrong equation and surgically corrected it with a precision that defies all probability. The cosmological constant appears to be fine-tuned, not just to allow life, but to cancel out what should be the most dominant force in the universe with an accuracy that approaches the impossible. This leads us into even stranger territory. Some of the most brilliant minds in physics have proposed that our universe might not be fundamental reality at all, but rather a kind of holographic projection. The holographic principle suggests that all the information contained in a volume of space can be encoded on its boundary, like a three-dimensional image projected from a two-dimensional surface. What this means is that everything you experience, every star you see, every breath you take, every thought you think, might be information encoded on the distant boundary of the universe. You're not really three-dimensional. You're a pattern of information written on a cosmic screen so far away that light from the edge of the observable universe is only just reaching us after traveling for nearly 14 billion years. The implications are staggering. If the holographic principle is correct, then the solid reality you experience is more like a shadow cast by something far more fundamental. The universe as we know it might be similar to the shadows on the wall of Plato's cave, mere projections of a deeper reality that exists in fewer dimensions than we can directly perceive. But even this mind-bending possibility doesn't answer the ultimate question. Whether our universe is three-dimensional or a holographic projection, whether it's fundamental or emergent, we're still left wondering why any of it exists at all. The holographic principle might change our understanding of the nature of reality, but it doesn't explain why there's anything to be holographic about in the first place. This is where we encounter what philosophers call the hard problem of existence. It's not just about understanding how the universe works, but about grappling with the fact that there's a universe to understand at all. Why should the laws of physics exist? Why should mathematics describe reality? Why should there be space and time for events to unfold within? Some thinkers have suggested that existence might be inevitable in some way we don't yet understand. Perhaps nothingness is actually impossible. Perhaps reality is self-creating. Perhaps the very concept of non-existence is incoherent. But these ideas, while intriguing, feel more like philosophical speculation than scientific explanation. Others have proposed that consciousness itself might play a fundamental role in the universe's existence. In quantum mechanics, the act of observation seems to play a crucial role in determining the outcome of experiments. Some interpretations suggest that consciousness causes the wave function to collapse, literally bringing definite reality into existence through the act of observation. Could it be that the universe exists because it's observed? Could consciousness be not just an accident of cosmic evolution, but a necessary component of reality itself? The idea sounds almost mystical, but it emerges from the most rigorous mathematical framework we have for describing the behavior of matter and energy at the smallest scales. Yet even this possibility raises more questions than it answers. If consciousness is required for reality to exist, where did the first conscious observer come from? How did the universe exist long enough for consciousness to evolve in the first place? We seem to be caught in a loop of causation that bends back on itself in ways that make our heads spin. The deepest mystery might be that we can ask these questions at all. Think about it. You're a collection of atoms that somehow became aware of itself. The carbon in your body was forged in the nuclear furnaces of stars that died billions of years ago. The calcium in your bones was created in supernova explosions that shook galaxies. The iron in your blood was scattered across space by stellar catastrophes so violent they briefly outshone entire star systems. Somehow, through processes we barely understand, these scattered stellar remnants came together on a small planet orbiting an ordinary star in an unremarkable galaxy. They organized themselves into increasingly complex structures, developed the ability to reproduce and evolve, and eventually became sophisticated enough to contemplate their own existence and wonder about their cosmic origins. You are quite literally made of star stuff that has learned to question its place in the universe. The cosmos has evolved a way to know itself through your consciousness, to explore its own mysteries through your curiosity, to experience wonder at its own impossible existence through your sense of awe. This might be the most profound mystery of all. Not just that the universe exists, but that it has given rise to beings capable of recognizing the mystery of their own existence. We are the universe becoming self-aware, cosmic evolution developing the capacity for self-reflection, matter and energy organizing themselves into patterns complex enough to ponder the ultimate questions of existence. But even this beautiful perspective doesn't resolve the fundamental puzzle. Whether consciousness is fundamental or emergent, whether the universe is designed or accidental, whether reality is three-dimensional or holographic, we're still confronted with the basic mystery of why anything exists at all. Perhaps the answer lies not in what we can discover, but in what we can never know. Perhaps mystery isn't a problem to be solved, but a condition to be experienced. Perhaps the universe is constructed in such a way that its deepest secrets will forever remain just beyond our grasp, ensuring that wonder and curiosity will always have a place in our understanding of reality. The ancient Greeks had a concept called apophatic knowledge, the idea that the deepest truths can only be approached by acknowledging what we cannot know. Perhaps our relationship with the ultimate mystery of existence is fundamentally apophatic. Perhaps the most honest answer to why the universe exists is not a theory or equation, but a profound recognition of the limits of human understanding. Yet we keep searching, keep questioning, keep pushing against the boundaries of the knowable. Because even if we can never fully answer the question of why there is something rather than nothing, the very act of asking transforms us. It connects us to something larger than ourselves, something that transcends our brief existence on this small planet, orbiting an ordinary star. We are temporary arrangements of atoms that have somehow learned to wonder about eternity. We are finite beings capable of contemplating the infinite. We are products of a universe that has given us the ability to question our own existence and marvel at the impossible fact that we're here at all. And maybe, just maybe, that's exactly the point. The search for answers has led us down increasingly strange pathways, each more bewildering than the last. Scientists have built machines that can peer back to when the universe was just 380,000 years old, capturing the afterglow of creation itself in what we call the cosmic microwave background radiation. It's the oldest light in existence, a faint whisper from a time when the cosmos first became transparent, when electrons and protons finally cooled enough to form the first atoms. This ancient light carries within it the fingerprints of whatever processes shaped reality in those first moments. And what it reveals is deeply unsettling. The temperature variations across this cosmic background are almost perfectly uniform, varying by only a few parts in 100,000. This uniformity presents a puzzle that challenges our understanding of how the universe could have evolved. Regions of space that are now billions of light years apart show the same temperature, as if they had once been in contact, able to exchange energy and reach thermal equilibrium. But according to our models, these regions should never have been close enough to communicate with each other, even at the speed of light. It's as if you found that people living on opposite sides of the Earth, with no means of communication, had somehow synchronized their watches to the precise nanosecond. This is what cosmologists call the horizon problem, and it was one of the driving forces behind the theory of cosmic inflation. The idea that space itself expanded faster than light for a brief moment would explain how distant regions could have once been close enough to reach the same temperature. But this solution creates its own mysteries. What mechanism could cause space to inflate at such impossible speeds? What turned inflation on, and perhaps more importantly, what turned it off? The mathematics of inflation suggest that once it begins, it should continue forever in most regions of space. This leads to the concept of eternal inflation, where our observable universe is just one bubble in an infinite sea of expanding space, with new bubble universes constantly being created. Each bubble would have its own laws of physics, its own fundamental constants, its own version of reality. If this is true, then somewhere out there, in regions forever beyond our reach, there are universes where gravity works differently, where atoms cannot form, where the speed of light crawls at a snail's pace or races infinitely fast. There would be universes where time flows backward, where space has different numbers of dimensions, where the very concepts of matter and energy take forms we cannot imagine. The mathematical framework that describes these possibilities emerges from string theory, perhaps the most ambitious attempt ever made to unify our understanding of reality. String theory suggests that the fundamental building blocks of existence are not point-like particles, but tiny, vibrating loops of energy existing in dimensions we cannot perceive directly. According to string theory, the familiar 3 dimensions of space and 1 dimension of time that we experience are just a thin slice of a reality that contains at least 10 dimensions, possibly 11. The extra dimensions are curled up so tightly that we cannot detect them, folded into shapes so small they make atoms look like galaxies. The way these dimensions are folded determines the laws of physics we observe, the masses of particles, the strengths of forces. But here's the staggering part. There are an estimated 10 to the 500th power. Different ways these extra dimensions can be arranged. That's more possible universes than there are atoms in a trillion observable universes. Each arrangement would create a different reality with its own unique physics, its own version of what it means to exist. This vast landscape of possibilities is called the string landscape, and it presents us with a profound puzzle. If all these different universes are equally possible from a mathematical standpoint, why do we find ourselves in this particular one? Why do we exist in a universe where the laws of physics allow stars to shine, planets to form, and complexity to emerge? The anthropic principle offers one answer, though it's an answer that many scientists find deeply unsatisfying. Simply put, we observe a universe compatible with our existence because we couldn't exist in any other kind. It's a cosmic selection effect. We're not here because the universe was designed for us. Rather, we can only exist in the tiny fraction of possible universes where the constants happen to allow for our kind of complexity. But this explanation feels uncomfortably close to giving up on the search for deeper understanding. It suggests that the apparent fine-tuning of our universe is just a coincidence, that we happen to live in one of the rare cosmic lottery tickets where everything worked out just right for life to emerge. Yet the precision required is so extraordinary that coincidence strains credibility. Consider the cosmological constant, the energy density of empty space that drives the accelerating expansion of the universe. If this value were larger by even a tiny amount, the universe would have expanded so rapidly that galaxies could never form. If it were smaller, the universe might have collapsed back on itself before stars had time to create the heavy elements necessary for planets and life. The observed value of the cosmological constant is so precisely calibrated that it's like finding a pencil balanced on its point in a hurricane, not just once, but for billions of years. The probability of this happening by chance is so small that it approaches mathematical impossibility. Some physicists have suggested that the constants of nature might not be constant at all, but could vary across space or time. Perhaps what we call the fine-tuning of the universe is actually evidence that these fundamental numbers can take on different values, and we simply happen to live in a region where they've settled into values compatible with complexity. Others have proposed that the universe might be cyclic, going through infinite cycles of expansion and contraction, with the constants of physics being reset in each cycle. Perhaps the current universe is just the latest iteration in an endless series of cosmic experiments, and we exist in one of the rare cycles where everything happened to work out just right. But even these explanations don't address the deepest mystery. Whether the universe is fine-tuned by design, by chance, or by some mechanism we haven't yet discovered, we're still left wondering why there should be any mechanism at all. Why should there be laws of physics to be fine-tuned? Why should there be mathematical relationships governing the behavior of matter and energy? Why should mathematics, a product of human thought, describe reality with such unreasonable effectiveness? The mathematician Eugene Wigner once wrote about the unreasonable effectiveness of mathematics in the natural sciences. It's deeply puzzling that abstract mathematical concepts developed purely as mental exercises often turn out to describe physical reality with startling precision. The mathematics of curved spacetime developed by Riemann in the 19th century later became the foundation of Einstein's theory of gravity. Complex numbers, once considered mere mathematical curiosities, are now essential for describing quantum mechanics. It's as if the universe is written in a mathematical language that human minds are somehow capable of reading, even though we evolved to survive on the African savanna, not to unravel the deepest secrets of cosmic structure. Why should pattern-seeking primates be capable of understanding the quantum mechanical nature of reality or the relativistic behavior of space and time? This connects to an even deeper puzzle about consciousness itself. Somehow, the universe has given rise to beings capable of understanding it, at least partially. The same physical processes that created stars and planets, and the chemical elements of the periodic table, also created brains capable of discovering those very processes. We are collections of atoms that have learned to contemplate atoms. We are arrangements of matter and energy that have developed the ability to study matter and energy. We are products of cosmic evolution that have gained the capacity to understand cosmic evolution. The universe has literally evolved a way to know itself through our consciousness. But consciousness remains one of the deepest mysteries in science. We have no idea how subjective experience emerges from the electrical and chemical processes of the brain. We can map neural activity. We can identify which brain regions are active during different mental tasks, but we cannot explain why there's an inner experience of being you at all. This is what philosopher David Chalmers calls the hard problem of consciousness. It's not enough to explain the functional aspects of the mind, how we process information or respond to stimuli. The truly puzzling question is why there's a subjective, first-person experience of being conscious at all. Why is there an inner theatre where the movie of your life plays out, rather than just unconscious processing of information? Some scientists have suggested that consciousness might be a fundamental feature of reality, not something that emerges from complex arrangements of matter, but something that was there from the beginning. This idea, called panpsychism, proposes that even elementary particles have some rudimentary form of consciousness, and that our complex awareness is built up from these simpler conscious experiences. If consciousness is fundamental, then the universe's ability to know itself through conscious observers isn't an accident of evolution, but an inevitable consequence of the nature of reality itself. The cosmos didn't accidentally stumble upon consciousness. Consciousness was there from the first moment, waiting to emerge in more complex forms as the universe evolved. But even this profound possibility doesn't answer the ultimate question. Whether consciousness is fundamental or emergent, whether the universe is designed or accidental, whether reality consists of one dimension or 11, we're still confronted with the most basic mystery of all. Why does any of it exist? Any of? Perhaps we're asking the wrong question. Perhaps why implies purpose and intention in a way that doesn't apply to existence itself. Perhaps the universe doesn't exist for any reason. It simply exists, and our search for purpose is a projection of our own need for meaning onto a cosmos that simply is. Or perhaps meaning emerges from the universe's very existence, not as something imposed from outside, but as something that develops naturally when matter and energy organize themselves into patterns complex enough to contemplate their own existence. Perhaps we are not separate from the universe looking for meaning within it, but rather the way the universe creates meaning for itself. The questions keep spiraling deeper, each answer revealing new layers of mystery. And perhaps that's exactly as it should be. Perhaps a universe that could be completely understood would be a universe too simple to give rise to beings capable of understanding. Perhaps mystery isn't a barrier to knowledge, but its deepest expression. We stand at the edge of the known, looking out into an infinity of questions that may never be answered. And in that position, balanced between knowledge and mystery, between understanding and wonder, we might be exactly where we're meant to be. Not as accidents of cosmic evolution, but as the universe's way of marveling at its own impossible existence. The mystery deepens, and we are part of it, questioning and wondering and searching for answers that may forever dance just beyond our grasp. And maybe that's the point. Maybe the search itself is the answer we've been looking for all along. And yet, as we push deeper into these mysteries, we encounter something that challenges the very foundation of how we understand reality itself. It's a discovery that emerged from one of the most precise experiments ever conducted, and it suggests that the universe might be far stranger than even our wildest theories have imagined. In the early 20th century, physicists began to realize that the behavior of matter and energy at the smallest scales defies every intuition we have about how reality should work. They discovered that particles don't have definite properties until they're observed, that they can exist in multiple states simultaneously, that they can be instantaneously connected across vast distances in ways that seem to violate the speed of light. This is the realm of quantum mechanics, and it presents us with a puzzle that goes to the heart of what it means for anything to exist at all. According to quantum theory, particles exist in what's called a superposition, simultaneously occupying all possible states until the moment they're measured. An electron doesn't have a definite position or momentum until someone looks for it. A particle can spin clockwise and counterclockwise at the same time until the instant an observation collapses this ghostly superposition into concrete reality. The implications are staggering. If quantum mechanics is correct, then the solid, definite world we experience is just one possibility among many, crystallized into existence by the act of observation. Before measurement, reality exists as a shimmering cloud of potential, a mathematical description of what could be rather than what is. But here's where it gets truly unsettling. Some interpretations of quantum mechanics suggest that every possible outcome of every quantum event actually occurs, but in separate, parallel universes. When a particle's wave function collapses and we observe it spinning clockwise, there's another universe where it's spinning counterclockwise, and another version of you observing it. This many worlds interpretation implies that reality is constantly branching, splitting into countless parallel timelines with every quantum interaction. There are versions of you where you made different choices, where history unfolded differently, where the constants of physics have subtly different values. The multiverse isn't just a collection of distant bubble universes with different laws of physics, but an infinite branching tree of possibilities where every conceivable variation of reality plays out. If this is true, then the question of why our universe exists becomes even more complex. We're not just asking why there's something rather than nothing, but why there's everything rather than nothing. Every possible universe, every conceivable variation of physical laws, every imaginable arrangement of matter and energy, all existing simultaneously in an infinite ensemble of realities. But quantum mechanics presents us with an even deeper mystery. The act of observation seems to play a fundamental role in bringing definite reality into existence. Before measurement, quantum systems exist in superposition. After measurement, they have definite properties. The transition from potential to actual seems to require something outside the quantum system itself. This raises profound questions about the nature of consciousness and its role in the cosmos. Some interpretations suggest that conscious observation is what collapses the wave function, literally bringing reality into existence through the act of awareness. If this is correct, then consciousness isn't just a byproduct of cosmic evolution, but a fundamental feature of reality itself, necessary for the universe to transition from possibility to actuality. The idea sounds mystical, but it emerges from the most mathematically precise theory in the history of science. Quantum mechanics has been tested to extraordinary precision, its predictions verified in countless experiments. Yet it suggests that consciousness might play a role in the basic structure of reality that we're only beginning to understand. Consider what this means for the ultimate question of existence. If consciousness is required to collapse quantum superpositions into definite reality, then perhaps the universe exists because it's observed. Perhaps the cosmos is engaged in a kind of cosmic self-observation, bringing itself into existence through the very act of becoming aware of itself. This connects to ancient philosophical traditions that have long suggested reality might be fundamentally mental in nature. But modern physics gives these ideas new urgency and precision. We're not talking about vague mystical concepts, but about mathematical relationships that can be tested in laboratories and verified through experiment. Yet even this mind-bending possibility doesn't resolve the ultimate mystery. Whether consciousness creates reality or emerges from it, whether the universe is mental or material at its foundation, we're still left wondering why any of it should exist at all. Why should there be quantum mechanics to govern the behavior of matter and energy? Why should there be consciousness to observe and collapse wave functions? Why should there be mathematical laws describing how possibility becomes actuality? The questions spiral ever deeper, each level of understanding revealing new depths of mystery. And perhaps this is exactly what we should expect from a universe complex enough to give rise to beings capable of questioning their own existence. Recent discoveries in cosmology have added yet another layer to the puzzle. Astronomers have found evidence that the expansion of the universe isn't just continuing, but accelerating. Galaxies are racing away from us faster and faster, driven by the mysterious dark energy that makes up the majority of the cosmos. But here's the truly unsettling part. If this acceleration continues, the universe is headed for what cosmologists call the heat death, a state where all the stars have burned out, all the black holes have evaporated, and space has expanded so much that particles are separated by distances larger than our current observable universe. It will be a cosmos of perfect darkness, perfect cold, perfect emptiness, stretching on for eternity. This ultimate fate raises profound questions about meaning and purpose. If the universe is destined for eternal darkness, if all the complexity and beauty and consciousness that has emerged over billions of years is ultimately temporary, then what's the point of any of it? Why should the cosmos go through the elaborate process of creating stars and planets and life and consciousness, only to have it all fade away into nothingness? Some cosmologists have proposed that even this apparent ending might not be final. Perhaps quantum fluctuations in the far future could spontaneously create new universes, new big bangs emerging from the vacuum of space. Perhaps the heat death is just another transition, like the end of inflation or the formation of the first atoms, leading to new phases of cosmic evolution we cannot yet imagine. Or perhaps the very concept of ending is meaningless when applied to existence itself. Perhaps what we call the heat death is just our universe transitioning into a state we don't recognize as meaningful, but which contains its own forms of complexity and beauty and even consciousness that we cannot currently comprehend. The ancient Greek philosopher Heraclitus said that you cannot step into the same river twice, because the water is always flowing and changing. Perhaps the universe is like that river, constantly transforming into something new, never truly beginning and never truly ending, just flowing through endless cycles of change that we can only partially perceive. But even this perspective doesn't address the deepest question. Whether the universe has a beginning and ending, or flows through eternal cycles of transformation, whether consciousness creates reality or emerges from it, whether we live in one cosmos or an infinite multiverse, we're still confronted with the fundamental mystery of why there should be anything to transform at all. The search for answers has led us to the very limits of human understanding. to places where science and philosophy and even mysticism begin to converge. We've discovered that the universe is far stranger than we ever imagined, filled with dark matter and dark energy we cannot see, governed by quantum laws that challenge our basic assumptions about reality, possibly teeming with parallel worlds and alternate versions of ourselves. Yet for all our discoveries, for all our sophisticated theories and precise measurements, the ultimate question remains as mysterious as ever. We can describe how the universe evolved from the first moments after the Big Bang. We can map its large-scale structure. We can peer back to the edge of the observable cosmos and forward to its ultimate fate. But we cannot explain why any of it exists in the first place. Perhaps this is as it should be. Perhaps a universe that could be completely understood would be too simple to give rise to the complexity and consciousness that make understanding possible. Perhaps mystery isn't a problem to be solved, but a feature of reality itself, ensuring that there will always be new questions to explore, new depths to probe, new wonders to discover. We are temporary arrangements of matter and energy that have somehow learned to contemplate eternity. We are finite beings capable of grasping mathematical infinities. We are products of a universe that has given us the tools to explore its own deepest secrets, even if those secrets remain forever just beyond our complete comprehension. In the end, we may never know who or what created the universe, or why it exists at all. The answer may lie forever beyond the reach of human understanding, in realms of reality we cannot access or even imagine. But perhaps that's exactly the point. Perhaps we're not meant to solve the mystery, but to live within it, to be amazed by it, to let it fill us with wonder and humility and a deep appreciation for the impossible fact that we're here at all. The universe has given us the gift of consciousness, the ability to wonder about our place in the cosmic story, to search for meaning in the vast darkness between the stars. Whether that gift comes from a divine creator, from random quantum fluctuations, from the inevitable unfolding of mathematical necessity, or from something else entirely, it remains the most precious thing we possess. We are the universe becoming aware of itself, matter and energy organized in such a way that the cosmos can contemplate its own existence through our thoughts, can experience beauty through our senses, can feel wonder through our emotions. In us, the universe has developed the capacity to ask questions about its own nature and to marvel at the mystery of its own being. And maybe that's the closest we'll ever come to understanding why we're here. Not as accidents in a meaningless cosmos, but as the way reality has learned to experience itself, to appreciate its own impossible existence, to transform mere being into meaning through the miracle of conscious awareness. The mystery remains, as deep and profound as ever, but we are part of that mystery, not separate from it, but embedded within it, questioning and wondering and searching for truth in a universe that seems designed to fill us with awe. And in that search, in that wondering, in that endless questioning of our place in the cosmic story, we might just discover that we are the answer we've been looking for all along. The strange truth is that consciousness itself might be the universe's most elaborate magic trick. Think about it for a moment. You experience colors, but color doesn't actually exist in the physical world. What we call red is just electromagnetic radiation with a wavelength of about 700 nanometers. The redness you experience, that vivid sensation of crimson or scarlet, exists only in your mind. The universe is filled with wavelengths of light, but it took conscious observers to paint them with the palette of human experience. The same goes for sound. There are pressure waves moving through air, compressions and rarefactions that can be measured and mapped, but the melody of a symphony, the crash of thunder, the whisper of wind through leaves, these exist only in the theatre of consciousness. The universe makes no sound at all until there's someone there to hear it. This raises a possibility that's both beautiful and terrifying. What if consciousness isn't just along for the ride in cosmic evolution? What if it's the point? What if the universe spent 13.8 billion years arranging matter and energy in increasingly complex patterns specifically to create observers capable of experiencing beauty, wonder, and meaning? Consider how unlikely this seems from a purely materialistic perspective. Why should random arrangements of atoms develop the capacity for subjective experience? Why should there be anything it's like to be you, rather than just unconscious processing of information? The fact that there's an inner world of experience at all is perhaps more mysterious than the existence of the outer world we're trying to explain. Some neuroscientists have tried to explain consciousness as an emergent property of complex neural networks, but this explanation feels incomplete. We can map every neuron, trace every connection, measure every electrical impulse, but we still can't explain why there's a subjective experience of being you. It's like trying to explain the taste of chocolate by describing its molecular structure. The objective facts are all there, but the subjective reality remains untouched. This brings us to one of the most profound questions in all of science and philosophy. Is consciousness produced by the brain? Or does the brain somehow tune into consciousness that already exists in some more fundamental form? The traditional scientific view is that consciousness emerges from neural complexity. But what if we have it backwards? What if consciousness is fundamental, and brains are sophisticated instruments for focusing and organizing conscious experience? If consciousness is indeed fundamental to reality, then the universe's apparent fine-tuning takes on a whole new significance. The constants of physics aren't just calibrated to allow matter and energy to organize into complex structures. They're calibrated to allow matter and energy to organize into structures capable of conscious experience. The universe isn't just arranged to permit observers, it's arranged to create specific kinds of conscious experience. This possibility connects to something physicists call the measurement problem in quantum mechanics. According to the mathematics, quantum systems exist in superposition until they're observed, at which point the wave function collapses and definite reality emerges. But what counts as observation? Does it require consciousness, or is any interaction sufficient? Some interpretations suggest that consciousness plays a special role, that the transition from quantum possibility to classical actuality requires aware observers. If this is correct, then consciousness isn't just a byproduct of cosmic evolution, but a necessary ingredient in the recipe for reality itself. The universe might literally depend on conscious observers to bring it into definite existence. But this leads to a puzzling chicken and egg problem. If consciousness is required for reality to exist, how did the universe evolve long enough for conscious observers to emerge in the first place? How can consciousness be both the product of cosmic evolution and the mechanism that makes cosmic evolution possible? One possibility is that consciousness exists at multiple levels, from the fundamental quantum level all the way up to the complex awareness we experience as human beings. Perhaps even elementary particles have some rudimentary form of conscious experience, and our rich inner lives are built up from countless, simpler, conscious moments, like a symphony constructed from individual notes. This idea, called panpsychism, sounds exotic, but it's taken seriously by some of the most rigorous thinkers in philosophy and neuroscience. It suggests that consciousness isn't something that magically emerges when matter reaches a certain level of complexity, but rather something that was there from the beginning, waiting to be organized into more sophisticated forms. If panpsychism is correct, then the story of cosmic evolution takes on a deeply personal dimension. Every atom in your body, every particle that makes up your neural networks, carries within it some spark of conscious experience. You're not just made of star stuff, you're made of conscious star stuff, ancient awareness that has been flowing through the cosmos since the first moments after the Big Bang. Your thoughts and feelings and experiences aren't separate from the universe looking in at it from the outside. They're the universe experiencing itself from the inside. Consciousness that has been present since the beginning, finally organized into a form complex enough to contemplate its own existence and wonder about its origins. This perspective suggests that the question of who created the universe might be fundamentally misguided. Perhaps the universe didn't need to be created by something external to it. Perhaps it created itself through the very process of becoming conscious of itself. Perhaps consciousness and cosmos are not separate things, but different aspects of the same underlying reality. The ancient Hindu concept of Brahman suggests something similar, the idea that ultimate reality is pure consciousness that dreams the universe into existence. Not consciousness as we experience it, bounded by individual minds and personal perspectives, but consciousness as the fundamental ground of being itself. What we call the physical universe might be the way infinite consciousness appears to finite minds embedded within it. But even this profound perspective doesn't eliminate the mystery. Whether consciousness is fundamental or emergent, whether it creates reality or emerges from it, we're still left wondering why there should be consciousness at all. Why should there be awareness rather than pure unconscious mechanism? Why should there be inner experience rather than just outer behavior? These questions lead us into territory where science, philosophy, and spirituality begin to converge. We're no longer just asking about the physical mechanisms that govern matter and energy, but about the deepest nature of experience itself. We're probing the boundary between the objective world that science studies and the subjective world that each of us inhabits. Recent discoveries in neuroscience have revealed that consciousness is even stranger than we thought. Studies of patients with split brain conditions, where the connection between the left and right hemispheres has been severed, suggest that what we experience as unified consciousness might actually be multiple streams of awareness that are normally integrated but can be separated under certain conditions. Other research has shown that much of what we think of as conscious decision-making actually occurs unconsciously, with consciousness serving more as a narrator that creates stories about decisions that have already been made. Brain scans can sometimes predict what choice a person will make several seconds before they become consciously aware of their decision. These findings raise profound questions about free will, personal identity, and the nature of the self. If consciousness is more like a story we tell ourselves about unconscious processes than the driver of our behavior, then what does it mean to be a conscious agent in the universe? Are we truly making choices? Or are we sophisticated biological machines with the illusion of agency? Yet even these discoveries don't diminish the central mystery of consciousness. Even if free will is an illusion, there's still the question of why there should be the illusion at all. Even if consciousness is just a narrator, there's still the puzzle of why there should be anything it's like to narrate. The hard problem of consciousness remains as hard as ever. Some researchers have suggested that consciousness might be understood through information theory. Perhaps consciousness is what it feels like to be a certain kind of information processing system, one that integrates information in specific ways and has access to its own internal states. But this explanation, while elegant, still doesn't bridge the gap between objective information processing and subjective experience. Others have proposed that consciousness might be understood through quantum mechanics. Perhaps the brain operates as a quantum computer, with consciousness emerging from quantum coherence effects in neural microtubules. But even if consciousness depends on quantum processes, this doesn't explain why there should be subjective experience rather than just quantum computation. The mystery deepens when we consider that consciousness seems to have a unique relationship with time. While physical processes unfold according to the laws of physics, consciousness creates the experience of temporal flow, the sense that moments arise and pass away in sequence. But physics suggests that time might be more like space, with past, present, and future all equally real. from the perspective of the universe as a whole. This creates what philosophers call the problem of temporal experience. If time is just another dimension like space, why do we experience it as flowing? Why does consciousness seem to move through time rather than simply existing at all times simultaneously? The answer might reveal something fundamental about the relationship between mind and reality. Perhaps consciousness doesn't just experience time. Perhaps it creates the experience of time. Perhaps the flowing, dynamic quality of temporal experience is consciousness organizing the information it receives into sequential narratives that make sense to finite minds. Without consciousness, the universe might be a timeless, four-dimensional block where all events exist simultaneously. This possibility suggests that consciousness doesn't just observe reality, it participates in creating the kind of reality that can be observed. Through the act of awareness, consciousness might be carving up the timeless, multi-dimensional whole of existence into the sequential, three-dimensional slices that we experience as moments unfolding in time. If this is correct, then consciousness isn't separate from the physical universe, but is the mechanism by which the universe organizes itself into the kind of structured, meaningful reality that conscious beings can inhabit. We're not just observers of cosmic evolution, we're participants in the ongoing creation of the kind of cosmos that can support observers. This brings us back to the ultimate question with a new perspective. Instead of asking who created the universe, perhaps we should ask how the universe creates itself through the evolution of consciousness. Perhaps cosmic evolution and the evolution of consciousness aren't separate processes, but different aspects of the same fundamental creative activity. The universe began as pure potential, quantum foam fluctuating in and out of existence. Through processes we barely understand, this potential organized itself into matter and energy, space and time, stars and planets, and eventually life. And through life, it developed the capacity for awareness, for experience, for consciousness. But consciousness isn't the end point of this process. It's the mechanism by which the process continues. Through conscious observation, the universe continues to create itself, to explore new possibilities, to discover new forms of beauty and meaning and complexity. We're not just products of cosmic evolution, we're the way cosmic evolution continues to unfold. In this view, the question of why the universe exists has a surprisingly simple answer. It exists because consciousness exists, and consciousness exists because the universe exists. They're not separate things, one creating the other, but aspects of a single, self-creating, self-experiencing reality that we can only partially comprehend from our limited perspective within it. The universe doesn't need an external creator because it creates itself through the very process of becoming conscious of itself. And that process of self-creation, self-discovery, and self-experience is ongoing. Every moment of consciousness, every flash of awareness, every instance of wonder and curiosity and awe is the universe continuing to create itself, continuing to explore its own infinite potential. We are not separate from this cosmic creativity, but are its most immediate expression. Through our consciousness, the universe experiences wonder at its own existence. Through our curiosity, it explores its own mysteries. Through our capacity for beauty and meaning and love, it discovers new dimensions of its own infinite nature. The mystery remains as profound as ever. But perhaps we are not solving the mystery so much as living it, embodying it, expressing it through every moment of conscious experience. Perhaps the answer to why the universe exists is not something we will discover, but something we are. The universe exists because we exist to experience it, and we exist because the universe creates us to know itself. In this dance of cosmos and consciousness, creation and awareness, mystery and meaning, we find ourselves at the heart of the deepest question ever asked. not as separate beings trying to understand an alien universe, but as the universe itself, awakening to its own impossible, beautiful, mysterious existence through the miracle of conscious experience. The story becomes even more extraordinary when we consider what happens at the boundary between the known and unknowable. At the edge of our observable universe, roughly 46.5 billion light-years away, there's a horizon beyond which we can never see. Not because our telescopes aren't powerful enough, but because the light from those regions hasn't had enough time to reach us since the universe began. This cosmic horizon represents a fundamental limit to human knowledge. Beyond that boundary, there could be infinite galaxies, entire civilizations, phenomena that would revolutionize our understanding of reality, but we can never observe them directly. The universe might extend forever in all directions, filled with wonders and mysteries that will remain forever hidden from us. Yet this limitation reveals something profound about our situation. We exist in what cosmologists call a Hubble bubble, a sphere of space from which light has had time to reach us. Everything we know about reality, every scientific discovery, every philosophical insight, every moment of human experience has occurred within this tiny bubble, floating in an ocean of the unknown. The mathematics suggests that if inflation is correct, then our observable universe represents an infinitesimally small fraction of the total cosmos. It's like trying to understand the nature of Earth by examining a single grain of sand. The vast majority of reality lies forever beyond our reach, hidden behind horizons we can never cross. This raises unsettling questions about the nature of knowledge itself. How can we hope to understand the ultimate nature of reality when we have access to only a tiny fragment of it? How can we determine whether the universe is infinite or finite, designed or accidental, meaningful or purposeless, when most of the evidence lies beyond our cosmic horizon? Some physicists have suggested that the universe might be holographic, with all the information about the interior encoded on the boundary. If this is correct, then perhaps we don't need to see beyond our horizon to understand the whole. Perhaps the patterns we observe in our local region contain sufficient information to decode the nature of the entire cosmos. But even this possibility raises new puzzles. If the universe is holographic, then what we experience as three-dimensional reality might be more like shadows cast by information stored on a distant two-dimensional surface. The solid matter you touch, the space you move through, the time you experience flowing, all of it might be projections from a boundary so far away that light from it will never reach us. The holographic principle suggests that reality might be fundamentally informational rather than material. At the deepest level, the universe might not be made of matter and energy at all, but of pure information, with what we call physical reality being the way that information appears to conscious observers embedded within it. This connects to recent discoveries in black hole physics that have revolutionized our understanding of space, time, and information. When matter falls into a black hole, it seems to disappear from the universe, taking its information with it. But quantum mechanics suggests that information cannot be destroyed. This creates what physicists call the information paradox. The resolution might be that information never actually enters the black hole, but remains encoded on its surface, the event horizon. From our perspective outside the black hole, matter appears to fall in and disappear. But from the perspective of the information itself, it remains on the surface, stretched and scrambled, but never lost. This discovery has led to the realization that black holes might not be the destructive monsters we once thought, but rather cosmic information processors, encoding the history of everything that approaches them on their surfaces. Every particle, every photon, every bit of information that has ever fallen toward a black hole remains preserved in scrambled form on the event horizon. If this is correct, then black holes are libraries of cosmic history, containing detailed information about everything that has ever approached them. The supermassive black holes at the centers of galaxies might contain encoded information about the entire history of their host galaxies. Every star that formed, every planet that emerged, every moment of complexity that developed. But reading this information would require solving one of the most difficult problems in theoretical physics. The information is scrambled by quantum effects in ways that make it seem impossible to decode. It's like trying to reconstruct a book by studying the ashes after it's been burned, except the ashes have been mixed with the ashes of billions of other books and subjected to quantum mechanical scrambling. Yet some physicists believe that in principle, this information could be recovered. If you had perfect knowledge of the quantum state of a black hole and infinite computational resources, you could theoretically reconstruct the complete history of everything that ever fell into it. The universe might not forget anything, even when it seems to. And so we return to where we began, standing at the edge of an infinite mystery, no closer to final answers, but infinitely richer in wonder. We've journeyed through cosmic inflation and quantum mechanics, through dark matter and consciousness, through multiverses and holographic realities, only to discover that each answer opens doorways to deeper questions. Perhaps that's exactly as it should be. Perhaps the universe didn't create conscious observers to solve its mysteries, but to live within them, to experience the profound beauty of questions that have no final answers. Tonight, as you drift towards sleep, remember that you are star stuff contemplating stars, a temporary arrangement of cosmic dust that has learned to wonder about its own impossible existence. And in that wondering, you are the universe knowing itself, one conscious moment at a time, forever balanced between understanding and awe.